Hey guys, Oric here. I'm going to record the YouTube for the Chapter 7 Normal Distributions video, and I'm probably not going to do the whole test to just shorten this up a little bit, and I'll probably take a couple of problems from the practice test and a couple of problems from the review. They're really almost exactly the same. So when you look at the first problem on the practice test, this looks just like the problem from the review as well. So this 68, 95, 99.7 rule is using this sheet. That it's a note sheet that you guys should have, and what it tells you is the approximate percentage of area underneath a normal distribution. 0 being the mean, 1 and -1 being standard deviations away from the mean. And so when we have a problem like this first one that's oranges, you can put the mean here at the middle and add a standard deviation, add a second standard deviation. And if they're, say, use the 68, 95, 99.7 rule, then just add up the boxes. If it's between -1 and 1, then 68% of the data falls within that. If you add up from below -3 all the way to 0, that's 50%. If you add up all these boxes right here, that's 100%. So there's 100% of the area, and it looks different, but it's actually the same thing as when we use this sheet. If you look at the one side's negative, one side's positive, a z of 0, all that means is z of 0, you're at 50% is below the curve. So it's the same thing if you look at one standard deviation. I'll scroll down. Got some writing on here. Let me clear the ink. At 1, you're at 84%, 84.13. If I go back to this sheet, if I go to 1, I'm at 50% to 0 plus another 34, so I'm at 84%. So we're really doing the same thing. It's just the simplified version is using this sheet when our z-score, and that's how, once again, how many standard deviations above the mean you are, or how many standard deviations below the mean. If we land right on a whole number, then you can use this sheet. So practice test or review, some of these I did in class, but just so you know, and the first question is using that 68, 95, 99.7. Here's how you draw a curve, and 0 is in the middle. And for this problem, every single problem, they make a symbol sometimes like that. They'll give you the mean. Sometimes they say average. The mean is 6 pounds. I'll put 6.0. And the standard deviation, sometimes they make a symbol like this, sigma, and that is 0.5. So at 0, we're at 6. And if we drew the full curve, and this is where I'm going to save some time, we'd be at 6.5, add 1 standard deviation, 2 standard deviations, 3 standard deviations, and there should be very little data past 3 standard deviations. Go down 1, 5.5, like that. I should have gone on the low side because actually I can see from this problem here we want 4.5 and 5. So 4 would be 3 standard deviations. I'd be at a -3. -2 would be 4.5. 5.5 is at -1. And at 0 is our mean. What percent weigh less than 5 pounds? Oh, shoot, I did that wrong. Problem of not doing it ahead of time. 5.5 would be 1, 5, 4.5. And less than 5 pounds right here. Once again, you go back to this sheet. We're right here. We were at 6 pounds, 5.5, 2.5 less than 5 pounds. 2.35 plus 0.15, 2.5 pounds. Less than 5 pounds, 2.5%. Less, at least 4.5 pounds, that's basically everything. Everything over 4.5 pounds. Which is everything except, here's 4.5 pounds, everything except this amount right here. So that's going to be 99.85%. 99 point, I'm drawing with a mouse here, so it's sometimes kind of doesn't look very good. And what percent of bags weighed between 6 and 7.5? So we're between 0 and 6 and between 6 and 7.5. So we're at 1, 2, 3. Between 0 and 3 standard deviations, we got 34 plus 13.5, and we're right here, 0 to 3, 13.5 plus 2.35. Or we're at 50, because if you go from 0 all the way up, we're at 50% minus 0.15%. So our answer on the practice test for this one would be 49.85%. And you would do this problem exactly the same way. 103 would be in the middle. Add 5, you'd be at 108 for 1, 113 for 2. The middle 95%, is, if you look at here, here's the middle 95% right here. That's why it's called the 68, 95, 99.7. So it's from -2 to 2. So from -2, 2 standard deviations below would actually be, we would be subtracting 10 days and adding 10 days. So 113 days to 93 to 113 days. Less than 103, that's the mean. So less than, that'd be 50%. I wasn't even going to do that problem, and it was so easy that I did it anyway. When it talks about comparing z-scores, we have two things with different means and standard deviations, but we're kind of like ACT versus the SAT or whatever. If we use the same, use a different mean and different standard deviation, but put them on the same curve, whoever did better is, at the higher percentile. In other words, these numbers here, once we get out the higher positive number we get, that's going to be who did better. So this is the formula you use for all of these problems. Z equals, except for these kind of problems. These, when you do Z equals X minus the mean over the standard deviation, you could do this, but you'll get a number that's a whole number, 1, 2, 3, between 6 and 7.5. If I do 7.5 on a problem like this, it'd be 7.5 minus the mean, which is 6, over the standard deviation, which is 0.5, and I get a standard deviation of 1.5 over 0.5, which is 3.0. And I could look it up on the chart, but like I said, we're just going to use that for this kind of problem. But that's your z-score. That's how many standard deviations away from the mean you are. So we're comparing Jane and John. Let's put Jane here. Z equals X minus the mean, and I'm going to write the mean like this, over the standard deviation. I'll write like this. Looks complicated, but this one's always given. The mean's always given. Standard deviation's given. Compare their z-scores to see who did better. John did test A and Jane did test B. I'll put John over here. John got an 86 on test A. So his z-score, test A, I'll put an A over here, the mean was 79. So he got an 86 when the average person got a 79. So he did good. Standard deviation is 3.1. On the calculator, do the numerator first. 86 minus 79. 7 divided by 3.1. And you might even want to write that 7 divided by 3.1, 2.26 roughly. So he's 2.26 above the mean. You start getting that good on a test, you know, he's probably right about here. John is. So quite a bit better than most of the people. Jane, I'll do her in red. Jane on test B. Jane got an 82, but the mean was lower. So John got 7 over the mean. Jane got 5 over the mean. But the standard deviation's tighter, so the people most of the people are closer to the mean when the standard deviation's smaller. 2.1. So this equals 5 over, not the nice 5, 2.1. And I can tell that's more than 2. So let's see, 5 divided by 2.1. They're actually really pretty close, aren't they? 2.38. 2.38. So Jane did a little bit better if you compare these two. She's just a little bit higher than John is. All right, let's see where are we at here. I wanted to make this video about 20 minutes. Okay, well, these are kind of the same type of problems. Let's do this last problem, and all of these problems where you use the z-table, you're going to either find less than a certain amount, more than a certain amount, or in between a certain amount. So I'll try to cover all of that. Or they're going to give you the percentile and you've got to find the score. Shoot. I like it when I got... Okay, well, let's do this one. Let's do the kidney one. And I'll try to get a little bit of... Try to get one of each kind. A low, above, in between, and a percentile. Might have to use the next problem for the percentile. What proportion would be 4250 or more? So our mean is 4,000, and it's a good idea to draw a little graph like this. Standard deviation is 250. If you notice, this is exactly at 1 standard deviation. 4,500 would be next. So it doesn't say to use the 6895, but you could on this one. So this would be z equals, if you didn't notice that, which, you know, easy to not notice it, 4250 minus 4,000. Always subtract the mean, divide it by the standard deviation, and we will use our z-table this time. Would have sample be 4250 or more. So one thing that's nice about drawing this little graph like this is here is our 50 percentile mark. So if I'm going 4250 or more, I got to get an answer that's higher than, and it's going to be less than 50%, or going to get more than this. So we get 4250 minus 4000 is 250 divided by 250. We get a z-score of 1.00. So I'll use my table this time, but you could just look up here and go 1 or more. You got 13.5, 2.35 plus 0.15. That's 16%. So our answer should be roughly, and if you wrote an answer of 16% on this, that would be fine. But if you use the z-table, you look up 1.00, and that's the wrong one. Here's z-table. 1.00 is right here. We're at the 84 percentile, 0.84. Practice test. I don't know how that looks on the screen because I'm flashing back and forth. 0.84, what did I say? 0.8413. 0.8413, but it's actually 84%. Always is below. They always give us the number below. So 84% is this way. Nice color. 84% is this way. So 16% is above. So I have to do 1 minus 0.8413. 0.1587. And that's actually a little bit better answer. And you can leave it as 0.1587 or write it as 15.87%. And you can see 15.87%. Rounded is 15.9%. Round it to the whole number, 16%. What proportion of samples would have less than 3,300? Well, now let's see. We're at 3,750, 3,500, and 3,250 would be at -3. So we're down here pretty low. We're at like right here at less than 3,300. So to solve that, go 3,300. Oops, 3,300 minus 4,000 all over 250. That equals -700 over 250. Which equals -700 divided by 250, -2.8, and that once again is our z-score is -2.80. I go to my z-table. It's going to be on the negative side, -2.80, 0.0026. 0.0026 or 0.26% by moving the decimal place over 2. So that's pretty small amount. Between 3,500 and 4,000, I'm not going to do that. I'm going to just change this because I think I changed it on the test to make these two numbers the same. So between 3,300, just because I don't want to take the time to figure out the percentages for each of these, because that's what you need to do. You need to find the percentage for each of those numbers. But let's say we said between 3,300 and 4,250, since I already calculated those numbers. So at 4,250, we looked that up, and it was 0.8413. I actually just set my alarm, so that was about a 20-minute video right there. 4,250, and that was 0.8413. And so looking at my graph, 4,250 was at 1. We're at about right here. And that was 84% going this way. It was 16% because we looked above. But for our answer for part A. But it was 0.8413, and 3,300 is way down here, 0.0026. So we're just going to erase that little bit because we want to find out what's in between this amount, not all the way to the bottom. So it's right around 84% still because this was such a small amount. But to get an exact number, we would do 0.8413. You take our percentages. Don't subtract the z-scores and then figure out that amount. Figure out the percent for each, then subtract 0.0026 and 7, 8, 0.8387. So we're still at about 84% because we just subtracted off such a small amount. That's in between those two numbers. But you figure out the percentile for 8, the higher number, figure out the percentile for the lower number. Both of them give what's to the left, and so you take the percentile for the high, subtract off the percentile for the low. All right, and I'm going to do one more problem. For this problem, what score is at the 10th percentile or what score is at the 75th percentile? So just to give you a little graph, to do this problem, 290, you do 290 minus 300 divided by the standard deviation of 6. Look it up on the table, just like we did above. So our average is 300. What score is at the 10th percentile? 300 and standard deviation 6, so 1, 2, 3 standard deviations would be, well, it would be 294. It's down here a ways, 288. So what we want to do, 10th percentile, we're going to look it up on the table, the closest number we can find to 0.1000. So I look at my z table and find the closest one to 0.1000, 10%. So here's 1056, 1075, oh, going the wrong way, 10%, 0.1003. That's pretty darn close. And if you look up here, it's 8, and we're at negative 1.2, and then add 0.8, so it's negative 1.28 is our closest thing to 10th percentile. And that's our z-score. And then we use the same formula. So negative 1.28, practice test, negative 1.28 equals our score, and we don't know the score. This one you'd put 290 in to figure out what z is. Now we're trying to figure out the score, but you still use mean and standard deviation. 300, we know it's going to be less than 300 because it's down below it. And standard deviation of 6. Now to solve this, multiply both sides by 6. And when you do that, you got 6 times a negative 1.28. The next step is going to be adding 300 because I'm going to have x minus 300 equals negative 7.68. So I add 300 and 292.32. 292.32, and that's calories. That's what we're talking about here. You burn the 10th percentile only burns 292 calories. Just to do one last problem that's really similar, just to get another problem of working from the percentile and working backwards. 75th percentile would be closest thing to 0.7500. Let me change colors here. I'll go blue. So the 75th percentile is probably somewhere in here. At 1, we're going to be at 306. Actually, that's the 306 is the 84th percentile, if you remember from that one sheet. So it's probably a little less, probably somewhere around 305. Guessing is probably not a bad idea. So I'm going to guess 305, 304, 305, something like that. So the 75th percentile, look that up on my z-table chart. and it's going to be on the positive side. '75th percentile, here's 96. Oops, I'm going the wrong way here. All right, 77, 73, 74, 74, 75. So it's right in between. And you could actually do 0.075 if you wanted to be kind of accurate. But this one's 14 away from 75. This one's 17 away. But you're talking the thousandth decimal point. So it's not going to make much difference. We'll do 0.67. But if you did, like I said, if you did 0.68, that would be fine too. So positive 0.67. We're not all the way to 1.0, which was the 84th percentile. 0.67 is our z-score. Z equals x, which we're trying to figure out. I'm guessing around 305, minus 300, which is our mean, divided by the standard deviation was 6. Now I take 6 times 0.67, 6 times 0.67, and 0.67 is about 2/3, and 2/3 of 6 is 4. So we're going to be at about 304. 4.02 plus 300 to finish off the algebra, 304.02. And by guessing ahead of time, I know I'm almost positive that's the right answer. If I got a number like 294, then I know I probably added 300. I did something wrong here, or I was looking on the negative side, something. But by knowing that I'm going to be a little below 306 and I get a number of 304, I'm pretty sure I did that right. So that pretty much covers the practice test. The review has some similar problems. Make sure you ask me if you got any questions on any of those. There should be an answer key posted up on Google Classroom. And then, tell your friends, subscribe, give me a lot of hits. I end up making like a penny for every view. So if I get let's try to get 100 million hits watching this practice video, I could probably make $1 million and you can get rid of me as a teacher. Might be easier ways to do it than that. Take it easy. Bye.